not enough wind. Come on, we'll make bubbles instead. Look at the bubbles are flying in the wind. Yes, the wind. Do you want to know what it is? Come with me and I'll show you. Wind is a very complex phenomenon. It is a movement of the air particles in the atmosphere. It is very useful for mills to produce electricity or just to refresh a very hot summer day. But it can also be very dangerous, such as in storms. Wind is determined by many factors, such as temperature, relief, convection, or Earth's movement. So the temperature is one of the main factors of wind. Cold air is denser than hot air, and that is why the hot air is on the top. So when the sun hits the cold air, it becomes hot air and goes all the way up to the hot air zone with the evaporated water. Then the water condenses. And when the water condenses, just there, it produces a cloud. And it also refreshes the air. So the now cold air goes down like that and back to the cold air zone. And that is the cycle of the wind. Another factor is the Coriolis force. This factor is determined by the rotation of the Earth, because the wind will just go the other way around the rotation of the Earth. Relief can also influence the wind, because when you have a mountain, the wind has to go up and down the mountain, and that creates a movement. And in addition, you can even calculate its speed with a device called an anemometer. Yes, anemometer! The word anemometer comes from the Greek word anemos, which means wind, and the other Greek word metron, which means to measure. So anemometer measures the wind. An anemometer is a device that spins at the same speed as the wind. So if you measure the speed, you also measure the speed of the wind. And if you want, I even made one in Lego. No, not those ones, but we can use these. So I tied 2 Lego bars crosswise, and at each end a cup, which is half a Christmas ball. So when the wind will meet this cup, it will engulf in it because it is concave, hollow, and it will make the anemometer turn. But on the other side, this part is convex, so the wind will just go like that, and it will turn only in one way. It will rotate like that. Now we need to measure the speed. To do so, I made a system. So we have a small wheel with 20 holes in it, just like that, inside, which is spinning at the same speed as the spinning device. And on each side of the wind, there is a small thing like that, which is there a infrared LED, and there an infrared sensor. And a signal passes between the both of them. So when a hole passes between them, the signal can pass. But if there's no hole, the signal can't pass. So it's then easy to count the number of signals that passed, so the number of holes, and therefore the number of turns that the wheel made, which corresponds to the speed of the wind. Then, through this wire, the signal is sent to our good old friend Arduino. An Arduino card is a sort of mini computer which can calculate things with a program, plug wires, and send electrical signals. It is very useful when it comes to making DIY projects like that. So with our Arduino card, we can then easily calculate the speed of the wind with the number of holes per second. So now we have to program our little Arduino card in C, which is a common programming language. So this is the program. This is just some setup part, and this tells the program to do some calculations. So to calculate the number of turns of the wheel, we have to divide the number of holes that we encounter in 1 second by 20, because there are 20 holes in the wheel. And then we have to multiply this number by pi, which is 3.14, a number to calculate the perimeter of a circle, and the diameter to have the real speed of the wind in meters per second. So now that you're ready, why don't we try it? Just try it here with the fan. And it's working! Thank you very much to have watched this video, and don't forget to like. See you soon for another scientific trip. I think this time there's too much wind.